Hello and welcome to the Daily Space. It is, I hope and I think, May 12th. I think it's a Tuesday. We've hit this point in our year. So yeah, it is day quinzillion of sheltering in place. Today seems like a good day to discuss death and destruction. Our universe is, after all, trying to kill us. And some days, some years, that seems more apparent than others. Take the moon, for instance. This nice big rock in the sky is thought to have been formed when a Mars-sized object hit a trying to become Earth-sized object. And this messy collision led to a splash of a lot of lighter density materials and the merger of the higher density cores. Our planet, our Earth, is within a thin crust, and our oddly low density moon is the result. Here we are, a high density core and a thin crust, low density moon. It all matches a big splash. Our moon, like some Greek or Roman god, was born out of destruction, experienced 4.5 billion years ago. And the battering of asteroids, comets, and all manner of other objects, great and small, has continued ever since. These objects haven't just shaped the cratered surface of the moon, they've also impacted what minerals have formed. In new work from the Royal Ontario Museum, planetary scientists have found evidence of cubic zirconias embedded in moon rock. This mineral is often used as an alternative to diamonds and jewelry and is formed in hot, dense environments that exist in labs here on Earth or in the melting outer layers of worlds being impacted. Now, since jewelry makers aren't on the moon making these gems, well, we know something horrible happened in the past on the moon. This particular rock that is being studied was picked up during the Apollo 17 mission in 1972 and was protected for future study. It was hoped that as technology, sorry for the low mic, I don't know why it keeps resetting. It was hoped that over time, as technology advanced, we'd gain new abilities to learn from these precious rocks that were collected. In setting aside these rocks, NASA acknowledged we might not be going back to these places anytime soon. Although I'd like to believe they assumed we'd be going back to other places to get other rocks. Today, we do have better technology, although we don't have more rocks from other places. But this work, published in a new paper in the journal Nature Astronomy, describes how a team used modern microscopes to scan the minerals. Now, earlier I said they found evidence of cubic zirconia. What they actually found are batolite crystals that formed 4.3 billion years ago when the cubic zirconia that formed during a 2300 degrees Celsius impact heating reverted to a more stable mineral. Well, we can see craters and get a sense of the forces needed to excavate these large hollows on the surface of the moon. These microscopic minerals give us precise temperature limits. It was 2300 degrees Celsius or hotter. These rock melting temperatures would have driven mixing of inner and outer layers of the lunar crust, producing the complex array of rocks we see today. One of the reasons we study the moon is so we can get a better understanding of what happened on our own Earth. The mineral record here is much more confusing here on Earth due to plate tectonics and weather and other effects like, well, volcanoes. As described by paper lead author Lee White, rocks on Earth are constantly being recycled, but the moon doesn't exhibit plate tectonics or volcanism, allowing older rocks to be preserved. By studying the moon, we can better understand the earliest history of our planet. If large superheated impacts were creating rocks on the moon, the same process was probably happening here on Earth. So yeah, our world was beaten up too. We're just better at hiding our scars with a layer of vegetation and sometimes erasing them through weather, which, after all, can be seen as one form of exfoliation. Is that taking things one step too far? Anyways, these collisions in the earlier solar system are responsible for carrying rock and, well, other debris all over our solar system. We've known this for a long time, and it has been speculated that maybe life could be carried between worlds too, spreading life through a process called panspermia. As we send robot after robot to places like Mars, concerns have arisen that we may be forcing the issue, and our world's life could contaminate the fragile ecosystem of the red planet. In a new paper also appearing in Nature Astronomy, Edgar de Riviere Valentin and company looked at Mars' water cycle to determine just how big a problem contamination by Earth life could be. According to study co-author Dr. Alejandro Soto, our team looked at specific regions on Mars, areas where liquid water temperatures and accessibility limits could possibly allow known terrestrial organisms to replicate, to understand if they could be habitable. We used Martian climate information from both atmospheric models and spacecraft measurements. We developed a model to predict where, when, and for how long brines are stable on the surface and shallow subsurface of Mars. With this model complete, this team could look for the places and times that sufficient moisture exists at or near the surface of Mars to allow extreme life from Earth to exist. The result was, sure, life could exist, but it would die rather quickly. Roughly 40% of Mars' surface is thought to have liquid water seasonally, but that season is really short. It just makes up 2% of the Martian year, and that isn't a continuous 2%. The liquid exists for up to 6 hours at a time out of the nearly 25-hour-long Martian day. The team interprets this as meaning that we don't need to worry about, well, contaminating the Martian surface with Earth life while exploring, because Mars is fully capable of killing our bugs for us. Now, as we learned in Jurassic Park, which admittedly is fiction, but still has some pretty good life lessons, life has a habit of finding a way. But Earth life will face one hell of a challenge on the Martian surface. Planets and moons aren't the only places we see documented destruction in our universe. In today's final story, we have new images from the Chandra X-ray Observatory of galaxy clusters that have tried to pass through one another, and in the process have only torn themselves apart. Roughly 4 million years ago, two systems of hundreds of thousands of galaxies collided. Now, since both these systems were mostly empty space, the bulk of the stars and other dense objects just passed through each other without experiencing too large an effect. But the intergalactic dust in these systems collided, and gravitational tidal effects rearranged both systems. The resulting carnage glows brightly in the X-ray, where we see blue fuzz in this image. This is where hot gas in the cores of the two systems shines brightest, and a bridge of heated gas connects the cores. This system is collectively called a Bell 2394, and while it was discovered decades ago, this research, just now published, uncovered one surprising new detail. At the outskirts of the smaller of the two subclusters, a particularly active galaxy has a particularly active supermassive black hole with jets that are so powerful they are reshaping the bridge of material between the two systems. This work is described in a new paper in the monthly notices of the Royal Astronomical Society that was led by Viral Prek, and it follows the active galaxy from the X-rays out to the radio, where it is possible to resolve massive radio lobes pushing out and colliding with the hot X-ray gas, showing once again that to understand a system, you need to study it in detail using the entirety of the electromagnetic spectrum. In this case, they found one supermassive black hole able to drive the formation of jets that shape a 6 trillion solar mass bridge of material. The moral of this news is something small can have one hell of an impact on the mighty. From asteroid impacts shaping the moon to cold killing life on Mars to one supermassive black hole warping a massive pair of galaxy clusters. It's destruction all the way down. So be careful out there. And remember, the universe is trying to kill you. And that's all I've got. Today's episode was written by me, Dr. Pamela Gay, your host. The audio and video will be edited by Ali Pelfrey. Our content will be edited and posted by Beth Johnson. We are a production of a team of a myriad of volunteers, and we are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are brought to you by you. Your generous contributions, your bits, your subs, and your patronage at patreon.com allow us to pay our staff a living wage. And we really appreciate that. Thank you. And it's plague times. We know a lot of you are kind of in a bad way. We get it. We're here for you too. And if you can't support us financially, just come hang out. Come talk science. Come find a way to get involved. And just join us for a game. There is a never-ending turn of Ticket to Ride games on the Cosmic West Discord. Join us. All are welcome. Come as you are. All right, I'm now going to take your questions. So, Jillian Georgine, who did a fabulous job yesterday hosting our community coffee, she asks, this might be a dumb question also, but why don't inner planets have moons? They're too small, too close to the sun? We don't totally know. This is an excellent question, and no idea. Now, these smallest worlds, we originally thought probably didn't have moons because they didn't have enough gravity. But then there's Pluto with all of its moons. So yeah, don't know. Alara Sophia, thank you so much for your sub. Let me see if I can bring up Dog Cam. So for those of you who are new, we like to thank you by throwing bits to our dogs in exchange for your bits and subs to support us. Thank you, Alara Sophia. Thank you so much. All right. So yeah, not a dumb question. It's a question we don't know the answer to, Jillian. No idea. No idea. Tropical Tom, marked safe from deorbiting space junk falling uncontrollably. Blah. Yes, that. Good call, Tom. All right, let's see what else we have in here. So Jillian also asks, I saw something recently about a red hypergiant star. How is that different from a red supergiant star? So one of the things I'm really bad at remembering is the exact size of all of these stars. And it's a combination of both how massive and how big their radius is. Because stars change in radius throughout their life. And a hypergiant is a star that is a combination of quite massive and quite large. There are some amazing videos out there that will start off with our sun and then take you through the scale of all of these different stars. Someone in the chat can probably help you find one of these, and it'll really put everything into perspective more than just the numbers by themselves will. Yeah, broken symmetry. The galaxies colliding, square dancing is a good way to look at it. While these things started interacting only millions of years ago, they're going to continue passing back and forth through each other like pendulums held together by gravity rather than string, and eventually form one large cluster of galaxies that will settle into the typical spheroid of galaxies that we're used to seeing. Oh, that's cool. I didn't know that. Oh, yeah. Chandra has its own YouTube channel. I did know that. They do a lot of really cool videos, and they have submitted a lot of them to our 365 Days of Astronomy podcast. If you don't know about it, the 365 Days of Astronomy podcast, which is put together by Aviva Yamani and Richard Drum, it's a community contributed podcast that includes content from a variety of shows you're probably familiar with, our own Astronomy cast, Paul Matt Sutter's work, but it also includes individual contributions from people all over the world. And I hope you would all check it out and see what all it has, and maybe even consider contributing your own podcast. Tardigrades live anywhere. That is true, Chandra. But it turns out that if you cycle their environment too quickly, you can kill them. So tardigrades really like slow environmental changes. It may be possible for tardigrades to live in the craziness that is Mars, but they wouldn't thrive. And we wouldn't have to worry so much about them taking over the ecosystem as just struggling to hang on wherever it is they happen to get dropped. Let's figure out what else is in here. Yeah, I see your complaints about my mic. I'm not sure what I need to look up the software on my mic, because it seems to have picked up this weird habit that I will set the volume level on it and then ignore it for 6 hours or 8 hours or however long I get to sleep. And it will like auto adjust to a completely different audio level that is not where I left it. So I need to figure out how to get that fixed. So yeah, good to know. Thank you. We will sort. All right. So that is all I've got today. Now, we are working, as you may have picked up from the names I said at the end of the podcast, we're working on bringing on a variety of new people to help us out, not just as part of CosmoQuest, but as part of the Planetary Science Institute. And so because we were working to make sure that in the future we can bring you more and higher quality content, this week we're stepping things back a little bit. So today we did an episode. We were expecting to have a guest today. He needed to reschedule at the last moment due to an interrupting telecon. Let's face it, we're all ruled by Zoom right now. We will have a guest on Thursday. Thank you, Tropical Tom. Thank you so much. Do you guys want this? Do you want this? You do. Okay. Happy dogs. Happy dogs. Thank you. So there was supposed to be a guest today. Our guest had a last-minute conflict. We will have a guest on Thursday, and today's scheduled guest will instead be joining us next Tuesday. This week, as we work on bringing on the new humans and getting everyone up to speed on everything that's going on, we're only going to be doing a show today and a show on Thursday. Community coffee is going to be haphazard because you awesome community members, Jillian, Tim, I'm looking at you. You periodically offer to do amazing things, and we're not going to stop you. I, however, do need to focus on trying to get everyone up to speed so that next week, we can hit the ground as a fully operational content community machine. So we will see you on Thursday. Now, before I go anywhere, I know Oh Bother is streaming. Do you want to raid Oh Bother? Do you have other ideas on who you would like to raid? I am open to any and all ideas. Just let me know what you would like to do. This is me blathering while I wait for the lag so that I can see your responses. Other things going on this week. We will have Astronomy cast as normal. Tomorrow night will be the weekly space hangout. So yeah, stuff and things continues. Prof. Melko, Horizon Psi. So let's go to Horizon Psi and keep the astronomy flowing today. Please give Horizon Psi a warm CosmoQuest welcome. Are we sure Horizon Psi is streaming? Because he's showing as non-applicable with 0 viewers. We'll try this. Okay, here we go. We're going to try this. Oh, nope. Back. Did not click that on purpose. Stop. All right. Apparently he's streaming and he somehow doesn't have his title set and has 0 viewers. I'm going to assume this is Twitch being twitchy. All right. I have set up the raid. And so wherever you are, thank you for being here today. Today's episode was written by me, Dr. Pamela Gay. The audio and video will be produced by Ali Pelfrey. The content will be published by Beth Johnson. We are produced by a myriad of volunteers, including perhaps you. Thank you to all of you who help us keep going. We are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our universe and beyond. We are here thanks to the generous contributions of people like you. Your bits, your subs, your patronage at patreon.com/CosmoQuestX. You let us eat, and we like to eat, maybe a little bit too much. So thank you. And if you can't help out right now with a donation, that's okay. That's okay. You take care of you. And we're here to help. If you just need a place to hang out, come hang out with us. All the information on everything we do can be found at cosmoquest.org. So, wherever you are in the world, have a fabulous morning, evening, or afternoon. And remember, if you go outside, wear a mask. If you can, shelter in place. And together, we're going to get through this. So wash your hands, and we'll get through this. Bye-bye.